All right, well, we're still continuing with number 62. There's quite a variety of different problems involved here relating back to Unit 4. So let's see. This time I have 8 raised to the x power equals 15. Well, I think I'm going to need to use a logarithm here because I need to move this x down to a level where I end up with an x equals something kind of answer. Now the buttons on my calculator that I have are log and natural log. Quite commonly we choose log because base 10 is kind of convenient. We have 10 fingers and 10 toes, so log 10 is kind of convenient. If I apply the common log, log base 10, to 8 raised to the x power, and I apply the same log to the other side of the equation, now I can use my product rule and bring this x down here, so I'll have x times log base 10 of 8 equals log base 10 of 15, like that. Now the log of 8, that's something I can punch in my calculator and I can get a number out. But just so that I don't have to worry about rounding error, I haven't punched in the number yet. And what I'm going to do is I'm going to treat this as just a number, coefficient on x. And I'm going to divide both sides of the equation by the log of 8. So now this cancels out, that cancels out. I have an expression, x equals whatever that number happens to work out to be, and I'll plug it in my calculator. I'll punch in, I have to clear it out, so I'll punch in log 15, close parentheses, equals, divided by log of 8, close parentheses, equals 1.302, and let me go back and look at the directions for a moment. The directions don't tell me what to round to. So I think I could stop with 3 digits. Sometimes they'll say stop after 4, so I'll take 1.302296, like that, and I'll stop with a 3. And then we'll go and check the answer key and see where they wanted us to stop. But that will do it for now. Now I can take this x and I can plug it in here, and actually I can use a function on my calculator. I can put in the 8 and raise it to, and I'm going to use the second key and the negative sign down here, which has a and s on top of it, and it's going to take my previous answer and raise 8 to that power. And it happens to exactly equal 15. So my solution checks. So let's try letter F. All right. Anytime I see 27, 81, 9, things like that, I think 3. Because this is 3 cubed. That's 3 squared. So if I convert this to 3 cubed equals 3 squared, that's replacing the 9, raised to x minus 5, like that. Now I have to be careful to maintain this as an exponent and as something that is attached. Okay, so you might want to put an extra set of parentheses around it so that you can keep it straight. But you don't have to. But in this case now, I have 3 cubed is going to equal 3. And I can distribute the 2 to x minus 10, like that. And since I have the same base, the only way that this can be a true statement is if the 2 powers are equal. So I can rewrite this as 3 equals 2x minus 10. And, now I need to use my usual algebra tricks to dig that x out. So I'll add 10 to both sides. I get 13 equals 2x. I end up with, dividing both sides by 2, I end up with x equals 13 divided by 2. That's an improper fraction, but quite often in more advanced algebra, we keep our improper fractions and we don't even bother converting it to a decimal, usually. But let's see. Is this actually true? Well, if I plug it back in, I can have 27 equals 9 times 13 over 2 minus 5. And this is my check. So I'm asking the question, is this true? Well, now I think I do want to plug it in my calculator and actually get the decimal number for that. So 13 divided by 2, if you can't do it in your head, there, 6.5 minus 5. That's the power. So this is 9 to the 1.5 power is what we come up with. I'll write it in here. 27 equals 9 to the 1.5 power. Well, let's find out if it's true. We'll take 9, we'll raise it to our answer, and it happens to be true. So we did our work correctly. Hooray!